You've probably ridden a bike before, but beyond how you ride a bike or how the pedals drive the wheels, you probably don't know how a bike stays upright. What is sometimes used to explain this is the fact that the wheels are spinning. Therefore, the bike resists leaning. While this is true to some degree, it's neither everything nor entirely true. To start, let's look at that idea. The tires spin, and yes, there's a special effect you get when things spin. But it isn't that they resist tilting. On the contrary, they just don't tilt the same way. What is commonly used to show this effect is something called a gyroscope. A gyroscope is a toy with a heavy spinning disc in the middle. When you set the disc spinning and set the gyroscope on its edge, it doesn't fall over. This is where the idea comes from that spinning things resist tilting. However, if we look at the gyroscope more closely, something else is happening. If we simplify the setup a little, we are left with what looks like a large jack. This behaves the same as a gyroscope, but we don't have to look at as many points. As the jack spins, it has a tilt, because we aren't perfect at balancing things. Because of this tilt, there is a force acting on its center, pulling it further. But if we look at what effect this has on all the points along the edge, we can see why it doesn't actually fall. This point has a force on it pulling it down, but because it is spinning, it already has momentum. The resultant velocity vector is the sum of the two forces. So instead of falling, the point will move in this direction. But to do so, it has to tilt the entire disk this way. This is why a spinning object actually just delays the force acting on it by 90 degrees. In the case of the disk, a torque in this direction turns it into a torque in this direction. And this is why instead of falling, it actually just spins around. It precesses. That is why this is called gyroscopic precession. In the case of the bike, when the bike tilts, there is a torque acting to break the bike down. But because the front wheel is able to twist, this torque takes effect 90 degrees from the application point. So the front wheel turns into the lean, perfectly guiding the bike to get back under itself. But gyroscopic precession is not strong enough on its own to keep a bike up. In addition to this force, the bike has been crafted quite ingeniously. If we pay attention to the front wheel, you'll notice that the front steering shaft is tilted back from vertical. This moves the point where the front wheel contacts the ground slightly behind the axis it twists around. So, when the bike leans, there is a force on this point outward. But because it is behind the axis, it acts to twist the tire, once again turning the bike into the lean. With these two forces, even on its own, with proper speed, the bike can stay upright. When you add a rider, these just help to make it easier. But if the rider were to try, they could take advantage of these, and by leaning from side to side, steer the bike without even using their hands.